Hello everyone, my name is Felix Milligan and I am Principal Solutions Engineer here at Lightbits. This video series will teach you how to deploy Lightbits in Azure for Azure VMware Solution. Let's get started. First, let's check what we're going to do in this series. We're going to check the prerequisites that we need before deploying the cluster. We're going to create the Lightbits cluster itself as a managed application. We're going to add permissions to the Lightbits cluster so that we can use lbcli to initiate run commands against AVS. We're then going to configure lbavs, which is the command line tool for creating data stores, configuring networking, and all AVS operations to do with the Lightbits cluster. We're then going to configure the AVS networking to communicate with the Lightbits cluster. We're going to create a data store and vMotion a VM from vSAN onto the new Lightbits Datastore. And then we're going to do some snapshotting. So, in terms of prerequisites, if you want to follow along, feel free to, but what you'll need first is an AVS SCDC already deployed. You'll need run commands enabled for the AVS SCDC, and these are the VMFS run commands. You need permissions to deploy Lightbits and assign permissions to the Lightbits cluster, as well as the AVS resource group. And then you'll need to enable external storage for the SCDC, but we'll show you how to do that. Let's deploy the Lightbits cluster. As you can see, I've already deployed an AVS SCDC, and I'm taking a look at some of the relevant fields that I'll need to remember for later on when deploying the cluster. I'll duplicate my tabs so that I can stay within Azure, but also still have access to my AVS information. And then once this page is loaded, in the search bar, I'm going to navigate to the Azure Marketplace. Once in the Marketplace, I'm going to search for Lightbits in the search bar and choose the Lightbits Cloud Data Platform and the version I want, in this case 3.6.1. I'm going to choose the subscription I want to deploy in, and then optionally create a new resource group or reuse one that's already been deployed. I'm going to choose my region, and then also whether I want to deploy in single zone or multi-zone. In this case, I'm using a single zone AVS cluster in zone 2, so I'm going to select that same zone. I then give my application a name, and then I can also optionally change the managed resource group name that the application will use. Onto the cluster settings page, I'm going to edit the virtual network. In this case, I'm going to change the name of the VNet that will be created. And then I'm also going to ensure that the address space that the VNet is using doesn't clash with the AVS SCDC address space. Please note that if you are connecting straight to the SCDC and allowing Lightbits to create the express route, you will need to create a brand new VNet when you deploy the cluster. Next, I'm going to choose the VM size for each of the VMs in my cluster. You can see I can choose between LSV3 and LASV3. I'm going to stick to L16SV3 for the demo purposes. I'm going to choose my instance count from 3 to 16, and then I'm going to choose the username that will be used to SSH into the cluster. I then choose whether I want to generate a new SSH key pair, use one that's already in Azure, or paste in a key. I'm going to generate a new key pair, and that means I need to give my key pair a name. Because we're creating a new VNet, I won't need to add a user assigned managed identity, so I can skip this part. After clicking next, I'm going to give my resources a prefix so they're easily findable, and enable the Lightbits support team to SSH access to the cluster in case of support needs. And then I'm going to give my customer name, my email, and a phone number. Here, I'm going to check the box that enables Lightbits to create the Ultra Gateway with FastPath to my SCDC. And then I'm going to get some connectivity information from the SCD itself. Specifically, I'm going to go to the express route page. I'm going to grab the key, the authorization key for the express route. And I'm going to paste that into the box that says express route key. And then I'm going to take the express route ID. I'm going to copy that value and paste it into the express route address ID. The last thing I'm going to do is select a gateway subnet that will be used for the gateway for the connection for the express route. Just ensure that it falls within the VNet address range and that it doesn't overlap with either the cluster subnet or the function app subnet. I'm going to use the next logical address space. From here, I just review my entries. I need to click that I agree to the terms and conditions specified that Lightbits will deploy a managed application in my subscription, and Lightbits will manage this cluster for me if I choose to, and therefore resolve any problems that may occur. You can see I'm generating a new key pair, so it's going to give me the option to download the key pair, which I will for use later. And then it's going to create a deployment for this Lightbits managed application. This deployment will take around 30 minutes because I'm creating all the express route information as well as the resources. All you need to do now is wait for the deployment to complete. Let's add some permissions to the Lightbits cluster so that we can communicate with the run commands for the SDDC. As you can see, my deployment's complete. If I click on the parent resource group, you'll be able to see the SSH key that I created during deployment, as well as the managed application itself. If I click on the managed application, you can see some simple information about the managed application, including its resource group and managed resource group. When I go to parameters and outputs, you'll be able to see all the information I input when I deployed the cluster, as well as the support information that I chose. In order to see all of the resources that the managed application uses, we go into our resource groups and select the managed resource group that we created during the deployment. Here you can see all the assets that are created as part of the managed application, including the express route connectivity information. In order to assign permissions to the Lightbits cluster and use LB AVS, I need to click on the virtual machine scale set that houses the VMs, click on identity, and then user assigned. Here, I can see the user assigned managed identity that's assigned to the cluster during deployment, which is primarily used for the key vault identity. In order to assign those permissions, I'll go back to my AVS SDDC, and then I'll click on the resource group that the SDDC is deployed in. I'm opening up in a new tab so that I can access my managed application, my AVS SDDC, as well as the resource group. In the resource group containing the SDDC, click on IAM, then I click Add Role Assignment. The role that I want to assign is going to be the contributor role. As you can see, it's not in the job function roles, but instead, it's in the privileged administrator roles. I select the contributor role, click Next, and then assign access to managed identity and select members. I choose the subscription that my managed application is deployed in, and then I choose user assigned managed identity, and then search for the managed identity assigned for my cluster. It will be the resource name that I chose during deployment and key vault identity. I click Review and Assign, and now I've assigned the permissions to the Lightbits VMs, which contain LB AVS, so that it can initiate run commands against my SDDC. I'm going to assign one more set of permissions, and it's going to be so that I can access the Lightbits JOT, which will give LB AVS permissions to call the API of the Lightbits cluster. I navigate to the key vault that's a part of the managed application, the resource group, go to IAM, and then add role assignment. I'm going to select the key vault's secrets user, and after clicking Next, I'm going to choose user group or service principal, and then when selecting members, I'm going to search for my own email address or the email address that I've logged in with. I then review and assign, and after the assignment has been completed, when I select the secrets object, I'll be able to see all of the information about the secrets that are used within the Lightbits managed application, including the system JOT, which will be used to authenticate against the Lightbits cluster by LB AVS. Now that I've assigned all the permissions, let's check out the vCenter environment, what's already been deployed, And then we're going to add the CIDR range for an external storage, which is going to provide us with 2 new subnets in the environment, as well as 2 new VM kernel adapters per ASXi host. So I navigate to my SCDC, go to my VMware credentials page, and then copy the web client URL. I go to my jump host, which has access to this URL, then I paste it in the address bar. I launch the vSphere client, and then copy the username and password from my VMware credentials page. Once I've logged in, I see what's deployed by default as part of the AVS SCDC. Here you can see I have one cluster with 3 ESXi hosts. And if I go to the data store section, you can see I just have one single data store, which is a vSAN data store. If I go to one of my ESXi hosts and go to configure, you'll be able to see that I have 5 VM kernel adapters, and none of them have NVMe over TCP enabled. In order to create 2 new VM kernel adapters that I can then enable NVMe TCP over for connectivity to my Lightbits cluster, I go to my AVS SCDC, I click Storage, External Storage Egress Block, and then I add a /24 CIDR, which does not overlap with any other networks in my environment, including my SCDC, as well as any attached VNets to that SCDC. I then click Save, and this will initiate a deployment that will take around 20 minutes to complete. And by the time I come back, I'll have 2 new VM kernel adapters on 2 new subnets on each of my ESXi hosts in this SCDC. We're back, and you can see the deployment is complete, and now if I navigate to my vCenter, I can see that I have 2 new untagged VMKs per ESXi host that are all on the subnets that I created when I created the external storage address block. Let's configure the LBAVS tool. It's worth noting that in a future release, this step will no longer be required, so make sure you check the updated Lightbits documentation. In order to configure the LBAVS tool, I'll need information about my AVS SCDC as well as my Lightbits cluster. I'll also need to SSH into one of the Lightbits cluster nodes. So I'm going to select the VMSS for Lightbits cluster, click Instances, and then select Instance 0 from the VMSS instance information. I copy the private IP address, and then I'm going to use PuTTY from with my jump host to connect to this VM. If you're using PuTTY, you'll have a PEM file instead of a .ppk, which is what you'll need in order to SSH into this VM. You'll be able to see me create the ppk from the .pem file here, using the key that I downloaded when I deployed my Lightbits cluster. Now that I have this key, I can go into my PuTTY configuration to SSH and auth, and then in credentials I can choose the SSH key based on the ppk that I just created. I go back to my session, and I'm actually just going to save this session as instance 0, so I can SSH back to that instance easier. I'm going to use my username at the IP address so that it logs in straight away as my user using the key. And now I have an SSH session into one of my Lightbits instances. Inside the SSH session, I'm going to become sudo, and then I'm going to move the example lbavs.yaml file to a yaml.back file. Now I'm going to create a new lbavs.yaml file, etc lbavs lbavs.yaml. In this file, I'm going to paste the content from the documentation example page. It should look exactly like this. Inside this file, I'm going to replace anything with a $ and curly braces. So I'm going to grab the subscription ID of my SCDC by navigating to my SCDC and then copying the subscription ID and pasting it into the YAML file. I'm then going to add the name of my SCDC. As you can see, mine is Felix Demo AVS. Paste it into that section. I'm going to add the resource group that the SCD is deployed in. So in the overview section, you can see the resource group there. I'm going to copy it and paste it where it says group. And we're using a managed identity, so we can leave the rest of the AVSS section alone. We can move on to the Lightbits section. The endpoint is actually going to be a load balancer front-end IP. So I go to my managed resource group that my managed application uses. I go to the LB private resource front-end IP configuration. And here is the front-end IP address that will load balance any of my REST API calls to the Lightbits cluster. The last thing I need to enter is the Lightbits JOT, which gives me authentication to run API calls against the Lightbits cluster. I go to the key vault that's part of the managed application. I go to secrets and then system JOT. And I'm just going to copy the secret value and I'm going to paste it into this section. To make it easier to run LB CLI commands, we do add an export to the front. So make sure that you delete the export lightos jot equals and just leave the contents of the jot. Press escape, write quit or WQ. We're now going to test the configuration of LB AVS by typing in LB AVS space datastore space list. Then we're going to give a -v, and we're going to take the cluster name within the SCDC, which in this case is cluster-1 with a capital C. Yours will likely be the same if you're using a default SCDC. When I press enter and run this LB AVS datastore list command, if you navigate to the SCDC itself and then go to run command, once the run command page has loaded, if you go to run execution status, you'll be able to see that there's a get VMFS datastore execution that is running. And once this run command is complete, within the SSH session, you'll get an output which should say something along the lines of no data stores. If we get this output, we know that the configuration is correct. If we don't get any output, we know we need to configure or change one of the parameters in the YAML file. Now that LBAVS is configured and working against the SCDC run command APIs, let's configure all the networking so that we can connect the SCDC environment over the express route to the Lightbits cluster. In order to do this, I need to tag my new VM kernel adapters that I created with the external storage command. To do this, I type in lbavs network tag, and then I give it -e, and then I take the ESXi host name, and then -n, and I'm going to give the name of the VM kernel adapter, in this case VMK5. Once I press enter, it's going to go through the process of executing some run commands, and as you can see in the SCDC, it's a set NVMe TCP run command. If I refresh my vCenter a few times, eventually you'll see that VMK5 is tagged with NVMe over TCP as an enabled service. I'm then going to repeat this process for VMK6, and then I'm going to repeat that process with the rest of the ESXi hosts. Let's fast forward through this process. As you can see, I'm repeating the same process on the rest of the ESXi hosts with both new VMK adapters. The next big thing we're going to do is create the storage adapters for the NVMe TCP connectivity. I'm going to be creating 2 storage adapters per ESXi host. And to create these storage adapters, I'm going to be running lbavs network create. I'm going to give it -e, and again, I'm going to give the host name or the FQDN of the ESXi host. And then for the -n, I'm going to give the physical adapter name that's on the TNT DVS network, which should be VMNIC1 and VMNIC2. Start with VMNIC1, and as I run this lbavs command, what we'll see is in the AVS SDDC run commands, as well as the previous commands we've run, we should see new NVMe TCP adapter as an execution. This one's a quick one. If we navigate back to storage adapters, give the page a little refresh, we'll be able to see VM HBA65 or a similar number with NVMe TCP over NVMe over TCP storage adapter. Let's repeat this process with VMNIC2. And then I'm going to repeat this entire process with the other two ESXi hosts until I have 2 storage adapters per host. Again, I'm going to speed up the process of enabling or creating the storage adapters on the rest of the ESXi hosts for both the physical NICs. And once that's complete, what we need to do is connect the Lightbits cluster to the AVS SDDC. To do this, we use the lbavs space network space connect, and then we give the cluster name under -v. And when I run that command, you'll see that currently there are no controllers connected to the storage adapters. But by running this lbavs command, what we're doing is we're going through each of these storage adapters and we're connecting the storage adapters to each of the Lightbits targets within the managed application cluster. So if we have 3 targets, 3 VMs within that Lightbits cluster, each storage adapter for NVMe over TCP will connect to each of the 3 Lightbits targets. And that's what's going to happen here. You can see my first controller has already appeared with the subsystem NQN and some relevant information, including the Lightbits version that's installed. And as I speed this clip up, eventually we'll see that all of the storage adapters will be connected to all of the Lightbits targets. Now that everything's connected up, let's create a data store and then use the data store by vmotioning a VM from vSAN to Lightbits. As you can see, currently I only have one data store, and that's the vSAN data store. Within this data store I have an Ubuntu VM, which I'll be vmotioning over. If I go to my storage adapters on one of the ESXi hosts, you'll see I have no devices, even though I have controllers connected. In order to create a data store, go to lbavs and type in lbavs datastore create -n, give your data store a name, -v, and give the cluster name that you want to create the data store in. In my case, it's cluster -1. Give your data store a size with a -s. I'm going to make mine 1 terabyte in size. Give your data store a replication factor, in this case 3, so it's got 3 copies of the data in the cluster. And then I'm going to enable compression with -c. This is going to initiate a set of run commands, which if you go to your AVS SDDC and go to the run command section, in run command executions, you'll see that there's a couple of get VMFS hosts that we're understanding the environment with. And then eventually what's going to happen is Lightbits will create a volume on the Lightbits cluster, which will appear as a device as it has here. And the EUI designation is going to be equivalent to the Lightbits volume EUID. You can see it's 1 terabyte in capacity. And then after the device has been seen by the ESXi hosts, we then create a data store over that device. As you can see, once the data store has been created and the command is complete, you'll see the new Lightbits Datastore with the same naming convention and size that you designated using LB AVS. Once we get the output, you can see that EUID is the same as the EUI. Now I'm going to vMotion this Ubuntu VM across from vSAN into Lightbits. As you can see, inside this VM, I'm running some FIO just to show you that this can happen non-disruptively. So I'm going to go to my inventory, select my VM, change the storage over to do a storage vMotion. I'm going to select the Lightbits Datastore, go to Next, and then Finish. This is going to initiate a storage vMotion onto the Lightbits Datastore from vSAN. And as you can see, FIO continues to run even during the migration process. Now what you will notice is if you're using the built-in remote access from VMware, that once the storage vMotion has been complete, you will be kicked out of that session and you'll have to initiate another session like I have done here. Just go back into the VM, reconnect to it through the web console, and you'll get the session back and you'll still see that FIO job running. And that is how you create a Lightbits Datastore and then vMotion a VM from vSAN into the Lightbits Datastore. The last thing we're going to do in this video series is we're going to show you how to do some snapshotting of data stores. So as you can see, I already have a Lightbits Datastore, and then within the Lightbits instance, I'm going to list the Lightbits volume using the Lightos jot that I can also grab from the secrets of the Key Vault. You can see that my volume's there, the LBDS00, which is the same as my data store. And to create a snapshot, I'm going to run lbcli, give my jot, create snapshot, give -- project -name default. I'm going to give my snapshot a name with -- name. And then I'm going to specify the source volume name as my data store name. At this point, you can see that we return that the snapshot is creating. And if I do an lbcli list snapshots and make sure to give my project name being default, you can see that my snapshot is already available. Now I'm going to upload a random file. It's just a putty file, just so I have something within this data store. Could be full of VMs or full of files. But now I'm going to create a second snapshot. The only thing I'm going to do here is change the name to snapshot1. And I'm going to wait for the snapshot to be created. Should take a couple of seconds. There you go. It's now available. And from here, what I can do is I can restore a snapshot. And to restore the original snapshot, I do an lbcli rollback volume, give the project name being default. And then the next thing I'm going to do is give the name of the volume that I want to restore to. And then I give the source snapshot name that I want to restore from. And my source snapshot name would be the first snapshot I took, snapshot 0. And when I press enter, if you look at my vCenter, putty, when I refresh, will disappear. So you can see I've restored to my original snapshot state, And then what I'm going to do is I'm just going to roll back the volume to the second snapshot, which has putty added to it. And you can see after a refresh again, I instantly see putty appear. And that's how you take snapshots and restore with Lightbits in LB AVS with LB CLI. Please note that this was a quick demonstration about how Lightbits snapshotting works. But if you have real VMDKs and live machines on the data stores, we recommend that to recover data, you just use a cloned data store and then vMotion or replicate the data across.